Welcome to SEC403, 5 new security automations using AWS security services and open source. My name is Henrik Johansson. I'm a principal in our office of the CISO with AWS Security.
And I'm Andrew Krug. I'm a staff security engineer at Mozilla.
So today, as you might have guessed by the title, we're going to talk a little bit about AWS security services, but primarily we're going to talk about tooling. How to build your own tools, how to use other people's tools. We're also going to show a couple of new tools that we're going to release after this session that you can download and use in your infrastructure or use to learn. So we'll geek out a little bit. We're going to do a little bit, there we go, primer first to talk about security automations and sort of explain why we're here. And then dive into the actual different projects. So we're going to go through 5 different projects, hence the title. And then a little bit of lesson learned and stuff like that. So before we start, I like polling and I like asking questions. How many people work in a security role here? Nice. How many people work in an incident response on-call process? Decent amount? Cool. How many people have an active situation going now? That you know about. Otherwise, guard duty can tell you a lot. So we're going to talk a little bit about the primer. First off, why automation? Why do you want to start using secure automation? And we're going to talk about the different levels and maturity of secure automation and sort of how you move between them, but also a little bit of gotchas why you might not want to do some things. So first off, humans are awesome, unless you want consistent results. Then they start flaking a little bit. And especially when you wake up at 3 a.m. And the question you got to ask yourself is, when you wake up at 3 a.m., how many different API calls or how many different systems do you need to go to or how many people do you need to contact in order to disable that specific instance that is running cryptocurrency right now? Hopefully, it's just 1 API call or 2. But if you don't have access, you don't have information, you don't know where things are, what is running, what is the normal, or do you normally run BitCurrent or BitCurrency? Like, are you normally trying to do cryptocurrency mining on your instances? Probably not, but there are use cases. The second thing is that, how do you write that report after? How do you take all the stuff that you did, all the information you did, all the steps you did, and then write that report at 3:30. Hopefully you're done by 3:30. You have time for coffee as well. But how do you collect all that information? How do you know which information to collect? So a lot of times when we talk about secure automation, we talk about being reactive and how to fix things that broke in the middle of the night, or that broke because someone did a configuration setting they shouldn't have done, or someone made a mistake. But how do we flip from being reactive to proactive? And we can actually use secure automation to be proactive, and especially in a time of crisis. And if you don't know it, 3 a.m. is a time of crisis. I'm not expecting you to read this, because I can barely read from here. But this is just one way, and this is just an example flow, where you can figure out how to use automation to your advantage. So when you get that 3 a.m. alert call, that says that you have to wake up, at the same time, you can kick off a workflow. So in this case, you can kick off a Lambda function using CloudWatch events. If that alert comes through, for example, guard duty or any other source that can generate an event, you can kick off a Lambda function that will spin off a step function process that will go out and collect things. It could run, for example, an Athena query to collect information from CloudTrail containing all the information about, for example, instance, about the username, the IAM user, the role. It can collect all the information it needs from IP information from, for example, VPC flow logs. It can look if, what else we have? If you have, for example, remediation enabled and do a certain type of remediation to start isolating things. If this is an infrastructure where it's OK for you to isolate, it can kick that off as well. It can see if you have SSM and start doing inventory of the instances. And then take all these processors and collect it into one location, collect the state, because if you're using step functions, you have state management, collect that information, put it in a dashboard, and then when that person wakes up, you already have all the discovered data available to them. So now you actually took a reactive automation process, made it proactive, So when you sit in there, you already have all the information that you would run as normal commands. All of them are complete read accounts and read information. You don't have to go in and change anything. You're not going to do anything that's going to compromise the system. You're not going to tamper with any evidence. You're just reading metadata. Metadata is already available to you. And this is why automation is so much more than just reactive stuff. It's not just going to protect you and go in and disable things. It can also be used for information gathering. The second thing I want to just mention is what is actually a security service? We have the traditional one when people refer to AWS security services like Guard Duty, Inspector, Macy, Secret Manager, et cetera, et cetera. But there's also a lot of services that are AWS services used in security. We have Lambda. Lambda is the most amazing thing from a security perspective ever. How many people use Lambda in their security process? And are you using, keep it up if you're using CloudWatch events as well. Couple. Awesome. Like all of these are services that are services used in security. It's just names. Use whatever you need. Don't look at it as this is not a security service. If you can use it in a workflow, if you can use it in automation, make it into a security service. Make it into a service that supports your security processes. Doesn't matter if it's a runbook, if it's an automation, whatever it is, just look at them as services to support you. We also have, excuse me, the benefit of using security services together with, for example, open source. So we get the benefit of using managed services. It will take care of a lot of the heavy lifting. It will do a lot of the machine learning inventory. It's going to look at different sources. It's going to collect information. It's going to look at network heuristics, whatever it could be, and present that information to you. And it's going to integrate it with, for example, Cloud Shell. It's going to look at CloudWatch events. You can trigger off other workflows. It's going to look with Lambda. And that's where you can also trigger over to the other stores.
And then we have open source security software, which integrates with AWS's managed security services or provides standalone functionality on their own, which is why I'm here. Because open source security software allows us to collaborate and learn from each other in unique ways. It's highly adaptable, it moves fast, but it does require some know-how in order to navigate that open source space. But with the right amount of help, open source can be really easy to use to trigger AWS managed security services or other open source projects. So why would you consider using an open source product in your security organization? Show of hands, how many people use an open source product in their security program today?
Awesome.
Awesome. So I work at Mozilla. We're a company that makes a popular browser. I'm not here to talk to you about browsers. But our mission is to ensure that the internet is a global public resource, open and accessible to all. An internet that truly puts people first, where individuals can shape their own experience and are empowered, safe, and independent. I personally believe that security and privacy are really important components of a truly open web. And the more tools we all put out there, the safer the web becomes. So here's an assertion. Open source software helps us all be more secure. Open source projects are often vetted and community curated. More eyes often means better products. OSS projects go fast with your help filing issues and participating in community. Open source software developers are empowered to deliver the features that you need. Open source projects inspire others sometimes, even if they aren't complete. Code that you put out on the web might serve somebody else someday. And open source projects are often free or very low cost compared to commercial solutions. The corollary here is that sometimes companies have a hard time adopting open source software. Recently, my boss, Jeff Briner, did a talk where he surveyed a bunch of different companies on their concerns around using open source software. And this was just a few of the themes. So we'd like to clarify some of the, how you can address some of these concerns today and give you some examples of open source security software that you could use. One of the challenges can be, how do you assess project health when you're considering using an open source security product in your organization? Sometimes you go and you search on GitHub and you find just that tool that you need, but maybe it's not very well curated. Maybe it doesn't have any GitHub issues filed. Maybe it hasn't been active in years. This open source project that's up here on the screen is our product Mozilla Investigator. It's a managed threat hunting agent. You can see it has recent commits. It's got lots of GitHub issues. They're triaged. They're responded to, a healthy pull request ecosystem around it. But that doesn't necessarily always mean that that's a healthy project. Sometimes a product is just done. So it can be challenging sometimes to vet these things. And we all have to understand the implications of the licensing as well around the open source projects that we're going to use. So we're here today to inspire you to dive into open source software as a supporter, user, or contributor.
So, enough talking. Oop, there we go. Let's see some stuff. So we're going to go through different projects. We're going to show a little bit of code. We're going to show demos on some of them. Some of them are not suitable to show demos of because some of them include like go out and compromise your keys, and how fun that would be. It might take too long. We don't know. So we're going to show demos of the ones that's suitable. All the tools are going to be available after on GitHub, either under the AWS repo, or it's going to be under the Mozilla repo. You'll see which ones. Whoever's talking, you can guess which one it's going to be under. So the first one we're going to talk about is Signal Hub. And the reason why we have different types of projects here as well, we have some projects that are really small and really simple to use and really simple to write. And then we have some that have a whole staff behind them. A lot of people, a lot of contributors, and a lot of code behind it. And there's actually a purpose why we have so differentiated products. It's because it doesn't have to be tens of thousands of lines of code. It doesn't have to have a staff of 200 people or 10 people or 20 people, whatever it could be. It could be a small project that is just 100 or 200 lines of code, and it will still solve a big problem. Or it will solve that thing that you didn't have. So that's why go out and take a look at what's available, because it might just solve that problem you had without requiring a whole staff to manage. Also keep in mind that when you use these projects, try and keep to a framework. Try and keep to a simple structure that is repeatable. If you use a bigger project, it most likely have that already. But if you're writing something yourself, keep to a standard. So in case you write multiple tools, especially for incident response, if you need to go in and troubleshoot, you don't want to end up where, OK, is this written in Go? Is this written in Node, Python? How is the structure of it? What components are included? Where can I find this? Like, keep the same structure. So the first one I'm going to talk about is Signal Hub. It's basically a centralized messaging hub for alerts and other notification needs. Some of the purposes of doing this and how it works is that it basically has the ability to run in a per account or per organization or multi-account strategy, where you can invoke this from any other Lambda function without the need to build in messaging support into the different functions. It needs to be able to invoke from non-Lambda. So you can invoke it from command line. You can invoke it from any other tool you have. Needs to be able to send to multiple targets based on, for example, alert type, severity, input choice. So if you want to say that for this specific alert, I want to send it to these targets, or I just want to use whatever is default in the tool right now. Support different external systems, for example, Slack, Amazon Chime, Remedy, whatever it is you want to add to it, PagerDuty, for example. And that's the key. It's simple to add new targets. So we'll show that in the code as well. All the different systems are modularized, so it's easy to add a new target that you want to add and just add to the same message structure. Some of the challenges why we do this is that we want to be able to implement simple alerting. We want to be able so everyone in their Lambda functions, if it's for incident response, if it's for just regular automation of something, that they can add a simple messaging structure without having to reinvent the wheel multiple times and without having to figure out, OK, which channel do I send this to? Is this to the ops team? Is this to another team? Also, it can't interfere with SIM. A lot of the customers out here, a lot of people in this room have a SIM already that is doing messaging as well. This doesn't replace your standard process. This is a way so you can build into your Lambda functions a simple way to get message out what actually happened in the situation directly from the function without going through a big SIM process. And then the ability to add more targets, like I said. it should be easy to add, but it should also be easy to maintain. If you build in notification systems in all your different tools, and then try to go out and edit that, say, do you want to add a new target, and you have Lambda functions to do IR spread across 1,000 accounts, that maintenance is fairly heavy. Putting it in one message hub simplifies that maintenance a lot. Again, this is one of those tools where it's really easy. It's a super easy flow. It's basically invoked with a payload, either manually, or it could also be invoked by guard duty directly, where you don't have to do anything. So if it's invoked by guard duty, it's just going to sense that, and then just use the information like severity from guard duty, and then just send to the default targets that is set up as the ops target in it. So it's just going to take that payload from either an external account or from the internal account, look at, is this guard duty? If it's not guard duty, prep the message based on the standardized structure that it takes the payload. It's just a JSON structure. If it is guard duty, it's going to use the structure that is in the event coming in. If you haven't seen how the events look, on the AWS website in the documentation, you can go in and see sample events for most of the services to see how they look when they get to CloudWatch events. So we have sample events there in case you just need to figure out what structure to use. It's going to evaluate those targets and see where do I send this. Basically, does the payload include target that you're trying to send to? Do you want to use the default channel, or do you want to send it to a customized location? And then it's just going to send out to those targets. It is extremely easy. It's a couple of 100 lines of code, or not even that. Not going to do a demo here because there's a demo part of the second tool. Because just sending a blank message is boring. Couple of items that I mentioned. When you build tools like this, to think about when you do the code, keep a standardized structure. Make a sane structure of what information do you actually need. So in this case, for example, the only thing that we need from people is which targets do you want to use. So payload can include, for example, all three. It can include one of them or two of them. Where do you want to send it? Do you want to send it to a specific URL? So the endpoint URL for example, Chime, Slack, or SNS. Or do you want to use the default one? So just keep it as easy as possible. You can add, for example, severity, if you want to send it with a different severity. You can also add on to the tool and say that if it's severity high, always send to everything. Spread the word. And then whatever message that you want to have as a JSON blob. This is just the simplest input target that you can ever have, just to send out something. And this can be called from any Lambda function. In this case, we also have, for example, if it's guard duty or not. It is really easy to see if the event comes from guard duty. As I mentioned, all the different services have sample events. And you can just go in and say, if the event source that is tagged in the JSON structure, if that event source is aws.guardduty, it's a guard duty message. If it, for example, has, and we'll show it in a later case, if it's trusted advisor, you're going to see a different event source there. And then simply send it to, or then go to the processing plan, depending on the service. And then create dynamic messages. Make sure that you add the information that is relevant to you. In this case, it's very simple. There's another tool I have out there that have a lot more information that is parsing from the event that is coming in. In this case, we want to make it super easy. What account is it? What region are we talking about? What's the severity? And then just add the payload message. And we want to add the payload message exactly as it's coming. The reason for that is that then you can just take that message and you can parse it elsewhere. If you want to, you can sort of make it prettier, extract some information from it, but always include the actual payload message so you can process it somewhere else as well. Also, like I said, modularized targets. In this case, this is the actual target module for Slack. If you want to add another one, you just add another target module. Don't mix it into the same place. Keep it isolated. The second thing I want to make sure you understand is the multiple target locations. Is that depending on what type of message it is, or depending on if you have the parameter in there, you might send it to different locations. In this case, the first one is if you're using the default one, and the second one is if you added a URL that you want to send it to. There's also another thing I want to point out here. For the first example, we're using URL lib. You see that it's using parameter store. If you want to send something to a location where you don't want to share that sensitive key, you don't want to share that HTTP endpoint, or it could be secrets, it could be access points, whatever it is. Use parameter store or secrets manager, of course, if you have that as well. If you need that management and you need the key rotation, secret manager. But otherwise, parameter store is a really, really simple to use tool that will allow you to store secrets encrypted with full IAM permissions and with support for parameters. So for example, username and things like that. And you will never have to document your HTTP endpoint or anything, so you can use this from multiple scripts and then just change it on the parameter store instead. Quick poll, how many people are using parameter store and have tested it? Awesome. I was hoping for many hands, but I wasn't sure. So this is just a simple tool that we're going to demo later on. A simple tool that does a simple thing. It sends messages, but it sends messages from wherever you want it to and to wherever you want it to, and it's still only about 120 lines of code. And this is an example where it doesn't have to be more complicated than that. The actual use case for this is another tool they're releasing. So this is Lambda Canary. How many people use Lambda functions for incident response? Couple. How many people use Lambda functions for any kind of security remediation? Couple. How many people have a canary to monitor that the Lambda functions you use are actually there and the right code? Okay. So this is a common problem. People use Lambda function, which is absolutely perfect. Spread them out over multiple accounts. Some cases, actually we'll talk about that later. I'll talk about the actual problem summary first. So Lambda Canary is basically a Lambda-based canary to verify existence of cross-account incident response resources and functions. It can be used for any type of Lambda function, of course. It doesn't have to be incident response. It serves really simple purpose. It's going to do cross-account validation to verify that the Lambda function is there. It will also do a code validation to verify that no one has tampered with the code that is expected to be there. So if you have a Lambda function in a different region, it's going to check that it's actually the one that you uploaded. And it's going to integrate with an alert function, in this case Signal Hub, if it finds any deviation from normal. A couple of the challenges here is, as we said, how do you know that the different functions are there? And this actually doesn't matter if you have one account or 1,000 accounts. Even if you have one account, and if you have 10 Lambda functions, and even if you have 2 Lambda functions, just knowing that those are the same function that you expected them to be. This becomes fairly complex after a while. So in case you have, for example, US East, US West, US West 2, you might have 2 Lambda functions in one, 2 other ones in the different one, and then 3 that matches 2 of them. And just maintaining that map and doing that manually is not going to happen. No one's going to sit down and actually start polling the different regions and see where you have those Lambda functions. So the way it works, very simple. There are 2 ways to trigger it. One is if there's a change happening. So if any time you see a change in Lambda functions, and you can set up filters to catch only the ones that matter to you, or on a scheduled basis. Just run it every day, every 15 minutes, twice a day, whatever it is that you want to run. It's lightweight. It just pulls the data from it. You don't have to do code line-by-line validation. It's just going to use the SHA for the different codes to validate that it's there. And we'll show you the example of how to actually do this as well. It actually gives you a separate benefit as well, because since it's going to use assume role, it needs to be able to connect to that account. It also needs to validate that you actually have access to that account with that assume role function. So in case the assume role fails, that means that there's probably other things in that account going on that you don't know about, because now you don't have your boilerplate roles set up in that account. And one thing that we often talk about is that in every account you should have at least a read role. You should be able to go in and do governance on that role, and governance on that account to know what is actually happening there. So what a function does is simple. Anytime there's a change, it's just going to fetch from a Dynamo table. It's going to fetch which accounts that you're interested in and which functions and what region they're in. And I'll show you how it looks. It's extremely simple. For every account, it's just going to assume the role. If it fails, it's going to document that, and then it's just going to go to the next account, because there's no point in trying to pull functions when you can't even get the role there. And then it's going to do per region, since it's region-based as well. And you might not run all the different Lambda functions in all regions. So for every region that you expect to have a function in, it's just going to check that region, verify that the function is there. If it's not there, it's going to move on to the next function. You can also add a separate module here to download the code for every function that is failed. Or for every function that mismatched, you can also download the code and store that for forensics, because that means that someone tampered with the function and someone tampered with the code in it. So extremely, extremely easy demo. I don't know if, can you see this? Hands up in the back if you can see the text. Awesome. So this is an extremely easy demo. All it does is get the information, get the function list, get the account list, do some cleanup, do some sorting, and then just start assuming roles in the different accounts. And I'm using extra verbose now, so you can see that it's just testing and spitting out a lot of information. It's going to validate the different accounts in the different functions in the different regions. And for every time it doesn't find it, it's just going to generate a simple JSON structure that contains which account, which function, which region it's supposed to be in, and what type of failure it had. So for example, in the first one, we see that it's an assume role failure, which means that we can't test anything else in this account because we don't have any access. So all functions failed in this account. And then we can see for the next one, for example, that the function is there, but there's a hash mismatch. That means that someone has tampered with the code. So someone has gone into that Lambda function and done edits they're not supposed to do because they no longer match with the master account. And then we have the second case, which is function not found. Someone simply didn't deploy the function that you're expecting to be there, and so on. And this is the only thing that you need, because now you know exactly the map of all your functions, whether or not it's real or not. Oops. Couple of highlights in this code. First off, assume role is extremely, extremely easy. Don't deal with static keys in all the different accounts that you're using. Even if you're scripting, tooling, whatever you do, use assume role. It is very easy. Simply do is, in this case, in this tool, we're going to call a sub-function called get credentials. It's just going to assume the role, run assume role with the account information that we want and the assume role name that we want to use. It's going to add a policy. So we're using a very strict policy that only has one thing, and that's get function, because that's the only thing we need in the IAM policy. So it's going to pass on a policy to that if you allow it. You can also restrict, of course, on the actual, you should restrict on the actual role as well. But you can also say that for this session, I only want this function. And if it fails directly, that means that you haven't done the prep job of getting access to that account. This is the only thing you need to validate if you have access to an account. This is the only thing you need for an assume role function. Once you get access, it's simply going to take those credentials and then create a new session against, for example, the Lambda function in this case, and use the secret keys and the access keys from that assume role. So anytime you need to do cross-account, this is all you need. And you can slim it down even further. I just like to add difference so I know what I'm doing. But this is the only thing you need. And if that fails, that means that you didn't manage the assume role and you don't have the prep account information. So how do we verify that it's the correct code? There are two ways to do it. One is to download the zip file and then do a SHA, like an MD5 or a SHA, whatever it is that you want to do. There's an easier way, and that's simply to use the SHA-256 that is actually in the account today. So if you do a get function for Lambda, it's going to contain a lot of information. It's going to contain a location that is valid for 10 minutes. So if you do a get function, you can actually download the code directly. It's just going to give you a temporary S3 URL where you can download and do comparison. Or if you want to store it for forensics, just download that information as well and download the code. It's simply the zip file and the deployment package for that Lambda function. So the deployment package contains everything that you had when you created the function. The configuration piece of the response from get function also contains a code, a SHA-256 that you can use for offline validation. There is a little bit tricky way to, when you have created your Lambda package, in order to get that value, you just run OpenSSL and get the SHA for the binary, and then you actually have to base 64 encode it to get the one that matches the one that we're using. The command to do so is in the bottom there. You can also do that in Python directly if you want to run a Python script that creates SHAs for all your packages, or just use OpenSSL directly. Couple of things to think about in these tools. Like I said, super easy to use. It's about 150 lines of code. Doesn't have to be more. And now you have a canary that can validate all your functions in all your regions. So if you're using Lambda for incident response, for security tooling, or anything, please use a canary to verify. So this is going to be available as open source after as well. If you want to use this, if you want to create your own, doesn't matter, just do it. If you want to do this at scale, you might want to think about step functions. And that's more if you have thousands of functions and thousands of accounts. It's a very lightweight tool that goes super fast to run. But if you're doing it at large scale and you start doing downloading, doing forensics and things like that, use step functions. It's awesome for state management and for tracking multiple paths at the same time. And for repeatability, of course, when you roll this out and roll out everything, use CloudFormation. Always use CloudFormation to deploy, or any other infrastructure as code tool. If you want to use a different one, that's fine. Just have a repeatable way of doing it consistent. I know we said that humans are bad at consistent things, but try and put it in paper and it goes easier.
All right, let's change gears just a little bit. I know that there's a lot of folks in the room that said that they are already using guard duty. So I had a quarter goal to turn on guard duty in every account that I'm responsible for adminning. I have hundreds of accounts that I have to keep track of and lots of different AWS regions that I need to work in, and I need to consolidate all of the findings from every guard duty detector in every region in one place. I had a really hard time doing that at Mozilla because we have some unique challenges in the way that we roll out our AWS account structure, the way that we use AWS organizations, and the way that we segregate the data that InfoSec is allowed to have access to. So I had to create this project with a colleague of mine who's been sprinting on this for the last several weeks called Guard Duty Multi-Account Manager. It's a cross-account role manager and configuration assurance for AWS Guard Duty. The goals here are pretty simple. We just want to make sure that Guard Duty masters are enabled in every single AWS region in the present and in the future. I think there's 15 regions that are non-Gov Cloud today, and maybe there'll be a new one by the time I'm done delivering this talk. We wanted to empower account owners as well to decide when they wanted to enable guard duty. So we like to give our customers lots of choice as a security team. We wanted to then manage the lifecycle of invitations to those member accounts and aggregate all the findings from all of the regions for all the detectors in one place. And we wanted that to end up in Amazon SQS. So guard duty is great, right? It's generally a one-click enable. It has a standardized event format for outputs, lots of different finding types. You can bring your own threat intelligence list. It's very flexible for enabling at scale, and the multi-account model does support invitations. But I have hundreds of accounts, and I don't necessarily control them all the time, and I need to get guard duty turned on and make sure that it stays on. This is a snippet from the AWS docs on guard duty. It's highly recommended that you enable guard duty in all supported AWS regions. I don't know about you, but I have no idea what region someone is going to launch a workload in, so the safest thing for me to do is just to make sure that it's always active in every region, and we know that guard duty only bills you for what you use. So if you turn guard duty on and there's no workloads there, that's just a nice safety check. The challenge here, this is also a snippet from the AWS docs, is that you cannot currently use the enable guard duty stack set feature to enable guard duty in multiple accounts at the same time due to the lack of AWS CloudFormation support. And cross-region data transfer is not necessarily supported. You might not want cross-region data transfer either in some set of circumstances, depending on what type of compliance you're subject to. But I'd like to have a choice of where I want all those findings to end up. So option 1 here was actually from the AWS samples repository. I like to do research before I decide to spend time inventing a new project. I want to make sure I'm not reinventing the wheel. AWS samples has a great blueprint out there for enabling guard duty in multiple accounts. It didn't necessarily meet all my requirements because I can't use stack sets. All of the folks at Mozilla that use AWS don't necessarily want to give me, as a security engineer, access to provision arbitrary resources in their account using stack sets. They're very privacy and security centric. So that didn't really work for me, and it was a command line based tool, and it didn't ensure the state over time. Option 2 is actually to go through the entire invitation lifecycle and chase down every account owner and send them an email in every region and ask them to be really nice and consistent. And that goes back to our point from earlier that humans are not necessarily as good as automation if you want consistent results. So option 3 was to build an idempotent piece of code to manage 100% of this life cycle. This was actually, believe it or not, the easiest way forward. So without burying the lead here, here's where the code is. And it's been available on GitHub since about 2 weeks before reInvent. It's in the github.com/mozilla.org. It's licensed under the Mozilla public license. You can pull this off the shelf, and you can use it today, provided that you have some of the same components that we have. So what are the prerequisites to do this? We use AWS organizations to manage consolidated billing for all of our accounts and know who the account contact is. And we have another component here as well that is a dependency that we had to create for this called CloudFormation cross-account outputs. It's a separate repository, but this is the magic glue that we use to know when an account owner actually wants us to aggregate their guard duty findings. So we give them a cross-account role that they provision in their account that gives us access to manage their guard duty detectors. It phones home to an SNS topic, registers a category and an ARN for that role, and then we know that they're ready for us to turn on guard duty in their account in every region. So here's how it works. We deploy this component that's called Guard Duty Invitation Manager in our parent account. In this case, this is the account that belongs to our security team, and it's different than our InfoSec, or it's different than our AWS organizations account. We assume a role, we describe AWS organizations to get the member accounts, and then we correlate that with a table of provision roles. From there, it's just an assume role loop, and we iterate through all those accounts and manage the invitation lifecycle. Guard duty, though, can potentially have a lot of different relationship states, and this is one of the problems that we wanted to assist in solving, because we don't know if once we provision a guard duty detector in a region that somebody doesn't go into an account and delete that detector, let's say, and create a broken relationship with a master. So this guard duty relationship state management will run periodically using a CloudWatch event, and it will continue to ensure the state of those invitations over time until that cross-account role is revoked. Now, I talked about how I wanted to future-proof for new AWS regions as well, because this code doesn't do me any good if a new region comes into play and I don't have guard duty turned on there. The Boto core team added a new feature just recently where you can actually ask for all of the available regions that a service is enabled in. So this is a nice, easy way to future-proof against new regions, because this call will continue to be updated in the library, and I can iterate over any new regions and ensure that a guard duty detector is wired up in that region and automatically active and collecting data. So once you have guard duty active in all of your accounts, there's detectors everywhere. We're getting lots of finding data in our master account. We need to address the cross-region data transfer aspect of things. So there's a second function here that runs that I call guard duty plumbing. It just generates a CloudWatch event in every region that a guard duty detector is in the master account only. It hits on every finding, and it sends that to an input SNS topic. That input SNS topic then goes and invokes a Lambda function. That Lambda function normalizes the data, because in my case, it needs to end up in a SIM. It outputs that to an SNS topic as well, and that ultimately ends up in a single SQS that has all of the findings for all of the regions, for all of the accounts that GuardDuty is active in. So the end result here is that I actually have a ton of messages in this SQS that I can do stuff with, and the data is completely normalized. The GuardDuty event format is pretty standard, and I love it. I think it's going to dictate how we respond to industry incidents going forward. But I need to normalize a couple of different things for my SIM, the most notable of which is ISO 8601 timestamps. Anybody who's ever done data normalization for a SIM knows that handling timestamps is really, really fun. And then I like to do a little bit of event enrichment on that to add some more tagging, right? Because my ability to filter that and alert on it in the SIM is only as useful as the number of detail fields that I can sort of query when I'm generating an alert. So our end destination for this, which you're going to see more about in a little bit, is actually Elasticsearch. That data, once it's normalized, becomes very easy to work with. The question that you might have for me is why would you want to store this in Amazon ES or an Elasticsearch cluster of your own? And that kind of is a nice segue into the next project here, which is MozDef, the Mozilla Defense Platform. How many people have ever heard of MozDef before today? Just a few. Hopefully that'll change.
Tell your friends.
Tell your friends. So MozDef is a SIM, and if you don't know what a SIM is, it's Security Information Event Management. Personally, I think it should be pronounced SIEM, but let's not go there. The purpose of a SIM is to enrich, gather, and store logs. We want to track life cycle of investigations and incidents. We want to provide an interface to correlate multiple pieces of data, attackers, investigations, and incidents. MozDef itself is a SIM that's built to be flexible. It's primarily built in Python and has a plugin architecture that allows you to customize it very, very easily. And it's also a microservices architecture. It's intentionally designed so that you don't have to use everything in MozDef to use MozDef. You can use any of the components that make sense. And in our case today, I'm going to show you how to output an alert to Amazon SNS, which you could chain to something like the message hub that Henrik showed earlier for common time series IOCs or undesirable behaviors in your accounts. So MozDef isn't new. MozDef is new to the cloud. MozDef is a project that we started at Mozilla in 2013. And we decided that it was time to make it more accessible to the public. So we got together in October of this year. 8 engineers spent 5 days to create what we call MozDef for AWS. For us, MozDef currently does run in production at Mozilla. It's our only SIM, and it ingests nearly 300 million events per day for a total active data set of 40 to 70 terabytes of data that we have at any given time to do after-the-fact timeline reconstruction or alerting. The goals of that meeting for us were to create a one-click launchable CloudFormation stack that you could use to deploy a semi-opinionated installation of MozDef and get up and running almost immediately. And for that reason, we decided to use as many managed services as possible to reduce the maintenance overhead for small security teams. So in this case, we use things like Amazon ES and Elastic File System for durable data. We also wanted this to embody Mozilla's security principles whenever possible. If you've never seen our security principles, they're on infosec.mozilla.org, and it's an excellent list of criteria for vetting projects or products. The architecture looks a little bit like this. It's got just a few components. Out of the box, in this deployment of MozDef, we're going to ingest AWS CloudTrail for you by default. If you don't have consolidated CloudTrail with global events turned on, we'll go ahead and activate for you. And we'll give MozDef the necessary permissions to activate an S3 bucket with all of your consolidated CloudTrail logs across region. We'll also ingest AWS GuardDuty findings using the GuardDuty multi-account manager template that I showed a little bit earlier. We'll spin up a web server that has a nice front end that I'll demo here in a minute. That web server is backed by a Mongo database that's persisted and durable in Amazon EFS, and will spin up Amazon Managed ES for you as well for that one store of all those normalized events. So it's kind of a combination of managed and unmanaged services. The unmanaged services here are the MozDef ingestion pipeline that takes in normalized data. It enriches the data, the alert pipeline, and the web UI. But we're going to continue to evolve this architecture, right, based on usage and feedback and GitHub issue triage. So we'd really like you to get in there and use it and let us know if this is useful or if there's certain things you think make more sense to break out to managed service or serverless. And the way you enable MozDef in your AWS account is actually just to go to the Git repository. In the read the docs documentation, there's actually a one-click launch button for this that'll just spin it up in your standard CloudFormation console. From here, you only need to give it a few different parameters to use, VPC IDs, instance sizes, an ACM certificate to use for SSL termination, and some OpenID Connect info, which I'll tell you a little bit about next. And where to pull all of the nested stack sets from. So we actually host a set of CloudFormation templates for this, but if you want to be a little bit paranoid and pull those nested stacks over into your own S3 bucket and pull the nested stacks from your own account, we'll empower you to do that as well. So why is OIDC required? If you don't know what OIDC is, it stands for OpenID Connect. I'm an identity and access management engineer primarily. I also do cloud stuff and incident response. So I really like single sign-on. I think having single sign-on for 100% of web properties really, really helps you be more secure. So we made kind of an opinionated choice here that this would all be fronted by this thing that we call our OIDC access proxy. And this is just an instance of OpenResty that has a little bit of Lua code in it that will enforce an OpenID Connect single sign-on flow. And there's a variety of single sign-on partners out there that you can use for very low cost or no cost to get SSO, including AWS Cognito. So once you've deployed the MozDef stack, success pretty much looks like this. You have a bunch of CloudFormation nested stacks that create very quickly, and it outputs 3 URLs, all fronted by that OpenID Connect access proxy. The first of which allows you to access Amazon ES's managed Kibana running in a private VPC. The second of which is raw Elasticsearch, which can be really, really useful if you have other tools that plug in to managed ES, and then our actual MozDef UI. As far as log ingestion, you might be wondering what we bring in. At Mozilla, we bring in tons of different events from every system imaginable, from wireless controllers to CloudTrail to door locks. But in this instance, we're going to go ahead and we're going to turn on our syslog ingestion pipeline for you, AWS CloudTrail ingestion, and if you're using the GuardDuty multi-account manager, we'll ingest that for you as well. Most of the ingestion code in here, and this is just a tiny snippet from an Elasticsearch worker that ingests CloudTrail data, only just assumes a role and then normalizes the data to the MozDef event format. In most cases, as a security team, the data that we're ingesting doesn't always live in the account that MozDef is running in, so we have to assume a cross-account role. So you'll find that most of the code in here really supports cross-account role access to do the data ingestion. From there, once we pick up the data, we normalize it to that same format that I showed earlier, adding details, categories, and we do some event enrichment. So every time we see an IP address, for example, we'll enrich that event with geodata. And there's tons of other enrichments in the project. So the result here is all of your data ends up in Kibana. And we think that's pretty beautiful. When all the data is normalized, it's all in Kibana, it's all indexed, and you can search on any of these fields. But that's only partly useful. The real power in MozDef comes from what's called the alert pipeline. The alert pipeline understands data in a lot of different ways, and it can alert on different kinds of things. So what might you want to alert on? There's different kinds of alerts. Single events, which are usually X actor did X thing. Someone logged into the root account, for example. Absence of events. When people ask me where they should start with alerting, I always tell them that dead man alerts are always better than nothing. If a system stops sending log data, you generally want to know. But the more interesting type of alerts, I think, are correlation alerts, where something did something in some number of minutes across a number of data sources that's suspect. So maybe you have multiple failed logins across multiple systems for the same IP, or in the case of GuardDuty Multi-Account Manager, maybe you've learned about the profile of a threat actor all of a sudden that's moving across regions, across accounts for your organization. Our alert pipeline is really simple to write for. We have a generic template and an awesome alert writer's guide for you to stub out alerts. From there, the meat of the alert is pretty much that Elasticsearch query there in orange. So you define a time series for the alert, what you want to pull back, and then the alert plugin pipeline will pull back that data, and then you can give it some criteria for when something does become an alert. This is an example here of an alert that adds a GuardDuty event for brute force to the pipeline. So let's have a look at the UI here. Yay. Okay. So the MozDef UI is very, very blue. As security engineers, we're not the most amazing UX people, so this is really, really functional. I'll just say that. If there are any UX engineers here who are also security people, I'd love to meet you. The first thing you'll see in the UI is that we have a drop-down that's auto-populated for any Kibana dashboards that do exist. So as you create Kibana dashboards, they automatically populate in the interface. From there, the next tab is those alerts. So for every alert that's generated, it shows up here, which is really nice if you have a team that's doing alert triage. Someone can come in and they can acknowledge an alert, which basically says, I, as a responder, am working on doing something with this alert. From there, that alert can become an investigation if it needs to. And we have a pretty rich set of forms for investigation and incident handling, up to and including Verizon's VerisTag system for reporting. So as you find root cause or you suspect that a specific investigation or incident falls in a category, you can actually tag these just by dragging over different VerisTags at different phases. And investigations can become incidents as well. So at some point we reach a conclusion that we are investigating an alert and it's become an incident. We can just copy all that data over into an incident, which gives it a whole new set of VerisTags and a whole new set of actions that we can associate with it. We take that all the way to the retrospective, which is any lessons that you might have learned during either the investigation phase or the incident phase that are all stored in this Mongo database, so you can go through and you can do retros with the team afterwards for cases, for example, where you might not have reached containment. We also have a fair bit of data viz, and I think this is one of the most popular things about MozDef, is that we have some really cool looking dashboards. We all like dashboards. This is the way that MozDef represents GuardDuty alerts from that brute force SSH finding type. So we have 8 different types of ogres that you can choose to represent the severity of threats. And they're sort of all running at you. And you can actually chain these to actions. So in our case, we actually have a function where we can look at these and we can click block IP, and that will really happen. It doesn't currently exist in the cloud-based deployment, but maybe you want to build a VPC black hole route plugin and pull that back into the project for us. I also mentioned the geo-enrichment feature. And I think this is a really nice graph as well, where you can see from a geo perspective what different geolocations are generating alerts for a time series. So that's actually quite nice as well. And as your SIM grows, you might also find that you need to understand more about its health as well. And this dashboards out lots of nice things like how quickly you're ingesting events, how much delay there might possibly be from an event generated to queuing it up to it going into MozDef, and the health of Elasticsearch. So the UI is actually quite nice for going through an entire incident lifecycle, triaging alerts, and doing data viz. People like to laugh at the ogre graph, but I think it's very useful, and it represents the most powerful feature in MozDef, which is that event correlation. And I've highlighted the line here from the actual code that generates the attacker graph, which is just saying for a given source IP, it had to hit this many times for an alert to go in the alert table that generates one of those ogres. And that is across the entirety of alerts that exist in Elasticsearch for the time period. So that's pretty useful. How many people think that is a correlation is a useful feature? All right. That will provide you some value.
Ogres?
Yeah, how many people want a dashboard in their office with ogres on it? Right? So today we have 76 pre-written alerts that live in github.com/mozilla/MozDef for just about every product that we use that we send data we get data from and ingest into MozDef. All of these alerts aren't activated out of the box for you because we don't want to make assumptions about your organization, but these are very easy to activate, and we produced a little bit of documentation to sort of help you get up and running and modify the CloudFormation to do that.
So the last one we're going to talk about super quickly because we're not going to show anything. This is more as a concept to understand a previous tool that we released called Exposed Keys Remediator. So it's basically a tool that will take, anytime you have keys that are exposed to GitHub or they've been compromised where you get an alert from, for example, Trusted Advisor and GuardDuty, it's basically going to go in and block those keys and all the temporary keys that were created with them based on the settings that you've chosen for it. And as you said, haven't we seen this before? Yes. The thing is, though, that that's always going to happen with your tools. You're going to create a tool that somehow it might be obsolete, might be needing updates, or what happens. Because sometimes we do release services now and then. And you need to understand what to do with it. So you can, for example, do you still need that tool? Can it be updated? Am I getting more value from it now with the added services? Like in this case, previously we used this tool for Trusted Advisor. Now, that tool also supports GuardDuty. So it's still valid, but it got another ingestion source. And this is how you will have to, there's no demo for it, but this is how you would have to evaluate your tools. Do you need to delete the tool, or do you need to add that extra source? Is this AWS Trusted Advisor? And this is going to happen all the time. Not going to go through the tool. Like I said, it's basically just going to disable access keys based on situation, and it's also support for temporary access keys. We talked more about this last year. The main piece of this is that it now supports GuardDuty, as I mentioned. And this comes down to, what is product health? What is the risk analysis? Do I want to do, for example, forensics, or want to do remediation? Remediation can be scary. What you have to think about is, what's going to be worse? Taking the service down by mistake, in worst case, or your information goes out somewhere else? And this is something you always have to do when you do evaluation around, especially automatic remediation. But as I said, automatic remediation and automation can be used for proactive things as well. A couple of gadgets and key takeaways. Automation is critical. Use framework and guardrail. Learn from others. All the tools we've demoed today and talked about are currently or will be available on GitHub. Some of them will be available on the AWS Security Automation repo under AWS Labs. We have threat response, WASA, there's a couple of different tools, Mozilla's GitHub repo. There's a lot out there that you can use currently.
So if you thought the MozDef thing was useful and you liked it, the easiest thing that you can do in support of that is you can go on GitHub and give it a star. If you don't have a GitHub account, go make one and give it a star if you think it's useful and you'll use it. You can also engage with us on Discourse. If you just Google Mozilla Discourse, it's the security category, and then you can try out MozDef for AWS, of course.
Thank you so much. One quick note, we also have a meet and greet after this in ARIA East Level 1 called the Willow Lounge. So if you want to come up and chat, we don't have any Q&A here, but we're going to be there for an hour, I think, or 45 minutes. Feel free to come by and chat with us. Reach out on Twitter, email. Absolutely complete the survey. We want your feedback. Otherwise, thank you so much.